So one of the most common questions students have when solving proofs is which rule, which deductive rule, interlem rule do I use to move forward in the proof? This is sometimes expressed as a worry. Students will say, or people will say, there's just so many rules, I just am overwhelmed. Now, this is a natural concern, and this video is designed to sort of fix that worry by giving you one rule or one tip for solving proofs or for selecting which rule to use when your proof has premises in it. So this rule will only really work. It's only something to think about when you already have some premises in your proof. Now, the rule or tip is this. Look at the formulas that you have as your premises. So just focus on the premises. Do not look at the conclusion. Next, look at the main operator of those premises. So for example, let's say you had a proof and it had these formulas in it. What you would do is you would look at the main operator of these formulas. Here we have the conditional, here we have the disjunction. Then, when you're looking at rules to use, you should focus your attention on elimination rules. So elimination rules are rules that have a sort of E after them that involve those operators. So in the case of line 1, you would focus your attention on conditional elimination rule. It's an elimination rule that uses the right arrow, which is the main operator of this formula. You would not focus your attention on conjunction introduction or conjunction elimination rule. These would not be, you could just ignore those as a kind of tip. In line 2 here, we have a disjunction, and so we would focus our attention on an elimination rule or some equivalent form of elimination rule that makes use of disjunction. So we would focus on disjunction elimination. We would not look at rules that involve, let's say, biconditionals or, I don't know, conditional introduction. Again, we're focusing on elimination rules that involve operators that are in our premises. So this is the tip to when you're trying to figure out which rule to use. Look at your premises, identify the main operator, and then focus your attention on elimination rules that involve that operator. Let's look at a couple of examples. So let's start with a really simple example. Let's say you had P and Q, and then you had, let's say, R, and you need to solve Q. Now, a lot of people can solve this particular proof, but I'm using it just as an illustration. You might say, well, I see all these derivation rules. I don't know which one to use. The tip is this. Look at your premises, which are at line 1 and line 2. You have P and Q and R. Identify the main operator in those formulas. Line 2 doesn't have any operators. Line 1 does. It's the sign for conjunction. So now that we know this is a conjunction, you should look at the corresponding elimination rules for conjunctions. You should not look at, let's say, conditional elimination or disjunction elimination or maybe disjunction or conditional introduction. You should look at the derivation rules that correspond to conjunctions. And in particular, you should look at the elimination rules that correspond to conjunctions. Now there's only one, and that rule is conjunction elimination. So you should look at that rule and try to apply it here. Now, if you did, you would get something like this. Let's say you applied it kind of blindly. You might say, well, the rule says that if I have a conjunction, I can reason to either one of the sides. And let's say you reason to the left side, you use conjunction elimination on line 1. And then you said, well, it also allows me to reason to the right side. So I can reason to Q. And so this is one conjunction elimination. And look at that. You have solved the proof because the goal of your proof was to get Q. And you weren't thinking about the conclusion in the process. You were simply looking at the formula and saying, what kind of formula is it? What is the main operator? Now let me direct my attention to rules that apply to those types of formulas. Let's look at another example. In this case, we have a little bit more complicated proof. We have a proof with 3 premises. 2 of them are complex well-formed formulas, and our conclusion is Q. Again, there's many deduction rules. Which ones do you use? I don't know how to pick. Common question, common worry. But again, our tip is if you have a proof with premises, look at elimination rules that correspond to those formulas. In other words, identify the main operator of each premise and then look at the derivation rules that correspond to that operator. So let's do that. In this formula, our main operator is this sign for conditionality. And in our second premise, the main operator is the sign for disjunction. We have the right arrow and the V. So what we should do is we should not be looking at, let's say, conjunction introduction or conjunction elimination or biconditional elimination. These we can ignore. Instead, at least as our first step, is to look at the elimination rules that involve the right arrow. And at least at some stage in your learning, the first one you're going to learn is the right arrow elimination. So you should look at this rule. You should ignore the rest and focus on this one and ask yourself, can I use this particular rule? In addition, the other rule is, or the other formula we have has the V or the sign for disjunction as its main operator. So depending on where you are, the rule that you might have is disjunction elimination. So you should ignore all the other rules and focus on these 2, at least to start your proof. Now, in our case, when we look at conditional elimination, that rule looks something like this. It says, if you have a formula and the first one's a conditional and you have the left-hand side of the conditional, then you can use conditional elimination. So this is the rule here. And so you want to say, can I use this particular rule? So the first thing you're going to need is, do I have a conditional? And we do at line 1. Do I have a formula that is the left-hand side of that conditional? And we do. We have a conditional, P right arrow Q. The left-hand side is P. We have P on its own line. And so this rule says we can reason to the right-hand side of that conditional. So we can reason to whatever psi is. And in this case, it is Q. So we can reason to Q at line 4. So this is 1, 3, conditional elimination. Now notice, we weren't really thinking about trying to solve the conclusion. We weren't saying, oh, how do I get the conclusion? Instead, our approach was, let's look at our premises, let's identify the main operator, and then let's apply the derivation rule that corresponds to that operator. In our case, we had a conditional and a disjunction. We focused our attention on the conditional, and then we applied the conditional elimination to get our conclusion. Let's look at one more example. In this case, it's a good idea to pause the video and try to solve it yourself. And in trying to solve it, I think it's a good idea to say, again, use our tip. Look at the formulas, identify the main operator, and then try to focus your attention on rules, derivation rules that correspond to those operators. Okay, hopefully you have paused the video. Let's work through it. In our case, we have a conjunction at line 1. So the main operator here is this and at line 2, the main operator is the right arrow. So we should look at elimination rules that have either the and or the right arrow. So again, we should focus our attention on 2 rules, the and elimination rule and the right arrow elimination rule, or conditional elimination. We should ignore, at least for now, all kinds of other rules, conjunction introduction, disjunction introduction, right arrow introduction. These are all rules, but they should not be our first focus. Okay, so we're going to say, let's start with line 1. We have a conjunction. That rule says that if you have a conjunction, you can reason to either one of the sides. So rather than thinking too far ahead in our proof, let's just go ahead and reason to both of the sides. So at line 3 here, we'll reason to P, and at line 4 here, we'll reason to Q and R. So P is the left-hand side of this conjunction, and then Q and R is the right-hand side. So both of these are from line 1 using conjunction elimination. So we've used conjunction elimination on line 1. Now let's look at the formulas in our proof. We have a conditional at line 2, and then we have a conjunction at line 4. When we look at conditional elimination, which is the elimination rule that corresponds to this operator, we can say to ourselves, well, I cannot actually use this rule, at least at this point. The reason I can't use this rule is because the rule has this form. And so in our case, we would need R all by itself in order to reason to the right-hand side. But we also have another formula in the proof that is a conjunction. If we look at it, the main operator is the and so we can use the corresponding elimination rule. So again, we're not going to think too far ahead. We're just going to identify the formula type, the main operator in the formula, and apply the corresponding elimination rule. So we could reason to Q and we can reason to R. And so this is from 4. We're using this conjunction elimination on line 4. All right, so let's look through our proof again. We've already used conjunction elimination on line 1, and we used it on 4, and we've essentially broken this formula apart. But let's go back to line 2. It's a conditional, and so we want to use conditional elimination. Conditional elimination is only possible provided we have a conditional, and then we have the left-hand side of that conditional. So we have a conditional, which is R, right arrow T, and so we would need the left-hand side of that conditional to reason to the right-hand side. So the question is, do we have R somewhere in this proof? And we do at line 6. So since we have the conditional R, right arrow T, and we have R at line 6, we can reason at line 7, to T. So this would be line 2, which was our conditional, and then 6, which was the left-hand side of that conditional. And so 2 and 6. And then the rule we used was conditional elimination, which was right here. It's illustrated right here. It's illustrated right here. All right, so what we've done here is looked at some premises and simply identified their main operator and then focused on the corresponding elimination rule that is tied to that operator. And if you see, we have our conclusion. We solved the proof without really thinking about trying to get that conclusion. We simply took these formulas and just kept breaking them apart using these elimination rules. So this is one tip for solving proofs that involve premises. Identify the main operator of the formulas in the premises, and then look or focus your attention on the elimination rules that are connected to that operator.